direct variation and inverse variation. First, let's look at direct variation. Let's say we have a variable y, and y varies directly with x. How do we set up an equation that represents this statement here? Well, we would do y is equal to kx. K is a constant, and x and y are our two variables. So y varies directly with x. They increase at the same rate. As x increases, y also increases, and our rate is going to be our constant. We would write this the exact same way if it said y is directly proportional to x. Direct variation and direct proportions are similar, and you would write them both as y equals kx. Now, what about indirect variation? Indirect variation is also sometimes called inverse variation or indirect proportion. So all of these mean the same thing, and so let's say we have our variable y, and y varies inversely with another variable x. How would we set up an equation to represent this statement? Well, in direct variation, we multiplied our constant and x. So if y varies inversely with x, it makes sense that we would write our constant and then divide by x. Both of these proportions go both ways. You can also write x is equal to k over y. And remember, k is a constant. In this first example, we are given 3 bits of information. Y is directly proportional to x. When y equals 20, x is equal to 6. And then we're asked to solve for y when x is equal to 21. So what is y when x is equal to 21? Well, let's look at this first part. Y is directly proportional to x. So let's set up a direct proportion. Y is equal to k times x. Now our second bit of information is y is equal to 20 and x is equal to 6. So let's set that up. Let's put y as 20 and then x as 6. And now we can solve for k. So if we divide both sides of this by 6, we will find that k is equal to 20 over 6, or 10 over 3. So now we have k, and we have our direct proportion here, so we can substitute our k in, and then we will have our final equation. So y is going to be equal to 10 thirds times x. And now let's look at our final bullet point here, which asks us to find what y is equal to when x is 21. So we know x, so let's substitute that into our equation here. So y is going to be equal to 10 thirds times 21. 21 times 10 is going to be 210, and then we can divide that by 3. And so if 21 divided by 3 is 7, then 210 divided by 3 is going to be 70. So y is going to be equal to 70. So when x is 21, y is going to be 70. So let's look at another example. Y varies inversely with x. When y is equal to 32, x is equal to 3. What is x when y is equal to 15? Let's look at this first bullet point. Y varies inversely with x. So let's set up an inverse variation or inverse proportion. Y is going to be equal to k over x. Next, we can substitute y and x to solve for k. So 32 is going to be equal to k divided by 3. So now we can multiply both sides by 3, and we will end up with k is equal to 32 times 3. That is going to be 96. So k is equal to 96. So let's put k into our proportion here, and we will get y. We will get y is equal to 96 divided by x. So because we need to solve for x here, before we plug in our value for y, I'm going to rearrange this to solve for x. So y equals 96x. If we solve for x, we can just swap the x and y. And so we will have x is equal to 96 divided by y. So now let's solve for x. X is going to be equal to 96 divided by 15. So what is 96 divided by 15? Well, both 96 and 15 are divisible by 3, so let's start there and divide them both by 3, and then we will get 32 over 5, and it doesn't look like that can be simplified anymore. So when y is 15, x is going to be equal to 32 over 5. Let's look at one final example. Y varies directly with the square of x. When y is equal to 17, x is equal to 4. What is y when x is equal to 2? So we see we have a direct proportion here, or a direct variation. So let's first write that out. We know that's going to be in the form y equals kx. But y does not vary directly with x. It varies directly with x squared. So what we can do is just put a squared here. Nothing special. Just y equals k times x squared. To emphasize this point, what if we had y is inversely proportional with the square root of x? We could just write that as y equals k over the square root of x. Y is inversely proportional to the square root of x. But let's get back to the problem at hand. When y is equal to 17, x is equal to 4. So we've done this before. Let's substitute this in. 17 is equal to k times 4 squared. 4 squared is 16. So now we can divide both sides by 16. And we will end up with k is equal to 17 over 16. So we know that y is going to be equal to 17 over 16 multiplied by x squared. So now that we have our equation for y, let's plug in our x value and solve. Y is going to be equal to 17 over 16 times 2 squared. 2 squared is 4. So 17 over 16 times 4. So that can be written as 17 times 4 over 16, which is 4 times 4. And then we can cancel these two 4's, and we will end up with y is equal to 17 over 4. So when x is equal to 2, y is going to be 17/4. And that's it for this video on direct and inverse variation.